Hello, Conanet Africa online students. Welcome to our second lesson on this topic of hydrogen and its compound. Today we are going to look at the chemical properties of water, and we're going to start with the reaction of water with metals. In our first discussion, we're going to look at the reaction with sodium metal, and we have an experiment that I'm going to discuss. And in this experiment, we normally cut a very small piece of sodium metal, the size of a rice grain. We normally cut it as a small metal because we are going to find that sodium is very reactive. So if you use a large piece of metal, it may end up igniting and hence being explosive. So this is the figure that demonstrates how the experiment is done. We have a trough, and this trough is filled with water, or a basin is filled with water. Then you cut a very small piece of metal, which is sodium or potassium. Then you place it on the surface. You can see it is actually floating. It doesn't sink in the water, which means that these two metals are actually lighter than water, or they're less denser than water. Then drop it into a trough containing cold water as shown in the figure alongside. Test the solution in the trough using piece of lead and blue litmus papers and record the observations. When a piece of sodium metal is placed in water, it melts into a silvery ball as it vigorously darting, as it reacts vigorously darting on the surface of the water with a hissing sound. The hissing sound comes from the production of the hydrogen gas. The resulting solution turns lead litmus paper or lead litmus solution to blue, which indicates that that solution is actually basic in nature. This is the reaction that is being involved, and this is the word equation for that reaction that is being involved in this trough. We have sodium plus water to give us sodium hydroxide and hydrogen gas. This sodium hydroxide is the one that is responsible for that color change of lead litmus paper from lead to blue, which indicates it's basic. And this is the chemical equation. In the chemical equation, we use the chemical symbols for the compounds and the elements and the molecules that are involved. In this case, we have sodium element. The sodium element is Na. Then the water molecule is H2O. Then the sodium hydroxide, we have the metal and the hydroxide group, which is an OH. It's represented, the hydroxide is represented by a OH. It's a radical. It's a negatively charged ion. Then we have the hydrogen gas, which is a H2. Then the reaction of potassium with water is very explosive. As you can see, potassium is more reactive than sodium, and hence that's why we have this flame that is indicated. If you use a small piece of metal, you're going to find that since potassium is very reactive, it's going to form a flame, or it's going to ignite to form a flame. And this ignition is as a result of potassium, the potassium powders that are being formed, and also the hydrogen gas that is being formed that normally ignite. Small piece is placed on water. It melts into silvery ball and moves about rapidly on the surface. The reaction generates a lot of heat, hence it is said to be exothermic reaction. And that heat is the one that actually causes or ignites the hydrogen gas that is being produced to form that flame. As a result, hydrogen gas produced ignites simultaneously, giving a lilac flame. And this lilac flame is as a result of the potassium vapor, which is being produced during the reaction. So you're going to find that in qualitative analysis, we normally check this color. If you get a lilac color in qualitative analysis, you know automatically that whatever ion is present in your solution is actually the potassium ion. Then this is the word equation, potassium plus water to give us potassium hydroxide plus hydrogen gas. So this is a hydroxide solution. So you expect this this solution to turn the lead litmus paper, or the lead litmus solution to blue, because it is basic in nature. And this is the chemical equation. Potassium is a capital K, then H2O for water, then potassium hydroxide. You can see also this OH, which represents the hydroxide group, and then the hydrogen gas. Then the reaction with calcium metal. So if you drop a piece of metal, calcium metal, into water in a trough, you see it sinks to the bottom of the trough, which means calcium metal is more denser than water, and that's why it sinks to the bottom. Then invert a funnel over the metal, sorry, and then collect the gas given off as shown in the figure above. Cork the test tube to prevent the gas from escaping. Then lift the test tube from the water and turn it upright. As you remove the cork, bring burning splint near the mouth of the test tube. Observe what happens. You're going to find that the solution obtained, you can also test with a piece of red litmus paper or a blue litmus paper. Record your observations, and when calcium is added to water, it sinks and reacts modestly with water, producing a steady streams of bubbles. We see that it sinks because it is actually slightly, it's actually denser than water. Then we have bubbles that are being produced, and these streams of bubbles indicate that we have the production of a gas, and that gas is hydrogen gas. When the gas is tested with a burning splint, it burns with a pop sound, indicating that the gas is hydrogen. So the test for hydrogen gas is by producing a burning or introducing a burning splint which burns with a pop sound if it is a hydrogen gas. The resulting solution formed is basic in nature, which means it turns red litmus to blue. A white suspension is observed because calcium hydroxide is slightly soluble in water. A water-soluble base is called alkali, just as in the case of in the case of potassium hydroxide and sodium hydroxide, which are soluble base. This is the equation, calcium plus water, to give us calcium hydroxide plus hydrogen gas. And this is the chemical equation. The chemical equation, you use the symbols. So calcium is capital Ca, that's the water. Then the calcium hydroxide, you can see the hydroxide group, and then the hydrogen gas. Then the reaction with magnesium, you're going to find that in case of magnesium, when you expose magnesium in the atmospheric air, it actually combines with oxygen from the air to form a thin coating of magnesium oxide on the surface of the metal. This coating has to be removed, or it must be removed before you react magnesium with water, because you're going to find that it actually protects the magnesium from being attacked by the water. Then magnesium reacts very slowly with cold water because of that thin coating, while zinc and iron do not react. Magnesium plus water to give us magnesium hydroxide plus hydrogen gas. That's the word equation, and this is the chemical equation. Magnesium. So you can see I'm introducing here the S. The S stands for solid because we know that magnesium is metal, and metals are solid at room temperature, and that's why you have that S to indicate that this magnesium is solid at room temperature. The water is liquid at room temperature, so yes, indicating the small l. This small l comes from the first letter of the liquid. It's L. When you write the word liquid, you start with L, so you use that L but a small l, then you put it into bracket. This indicates that the water is liquid at room temperature. Then magnesium hydroxide is a solution. It's a solution in which solvent. It is a solution in aqueous solvent, and aqueous is just water. Then we have hydrogen gas. It's a G from the word gas, because we know that hydrogen is a gas at room temperature. So this is a balanced chemical equation with state symbols. So this represents the state symbols. Then we have magnesium plus oxygen from the air to give us magnesium oxide. So magnesium is a solid at room temperature. We have seen that here. Oxygen is, it's gas at room temperature, so we use a G. Then magnesium oxide is a solid. It's a compound of magnesium and oxygen chemically combined, and it's a solid at room temperature. And that brings us to the end of our second lesson. So you have questions to tackle. In this assignment, you're supposed to tackle all the questions. There are 4 questions. So make sure that you tackle all the questions. Answer all the questions. There are 4 questions. And this will help you to see whether you have actually assimilated and understood this lesson. It's important not to copy. Just do your work, and because you're looking at integrity, we want to shape your integrity in this Colournet online school. Until next time, let's meet next time in our third lesson in this topic of hydrogen and its compound. Bye.